Yeah. So I'll make a start because then you can all get away to the pub soon. What? Is it turning it down again? Yeah. Does it auto adjust? I'm on the one you had. So I don't know. Is that better? Is that better or worse? That's better. Yeah. Okay. Thank you. Cool. Right. So my talk is called Learning to Go. My name's Tim Berry. I'm a little bit about me. I haven't done a slide about myself, but I'm a technical instructor at a cloud guru. You may not have heard of a cloud guru. You might have heard of Linux Academy. We just bought them. Yeah. But yeah, my talk is called Learning to Go, and this is the Go Gopher. He used to be called Gordon. He's now nameless after a specific Git commit. Can I start with a show of hands? Who here considers themselves a proficient Go programmer? You know, who does it on a daily basis for work or just fun? Okay, keep your hands up. Everyone else, look around. These are the people you need to ask questions at the end, not me. Everything I know is in this talk. I know nothing else. So who's a complete Go newbie who wants to learn how to use it? Brilliant. This is like me. This is who this talk is for. So this is going to be a show and tell. There's a few slides to start off with, and then we're actually going to do step by step. We're going to build a Go web application to try and learn a bit of Go. So we're going to try and build something that is relatively simple, mildly useful, and not boring. Those are the three criteria we're going to try and hit. And you might be thinking at this point, why? Why yet another tutorial? So the reason I came up with this talk, so this is mainly about my sort of personal learning experience with Go. I've been mucking about computers for a long time, and I've programmed in lots of different languages. Python is my sort of go-to language. I've done stuff in, I have certificates in Java that I never show anyone, and I've done stuff in C and even Objective-C. I kind of learned Objective-C just before Apple decided to stop using it. But every time I've tried to have a go at Go, it's for some reason it's just never stuck. I've gone through, you know, the tutorials, the famous ones, Tour of Go, Go by example, and they're too comprehensive, I think. You know, you can sit there and you can go through them, and you can you can learn the concepts in isolation, and as soon as you've finished, for me anyway, it just sort of falls out of my brain because there's no context to it. So nothing was really working. And then I was at Google Next in London in November, saw an amazing talk by Daniela Pretzuzalek. I probably mispronounced that. But it's a great talk, and it's all about how to build a Pac-Man clone in Go. And the way she did the talk was basically starting with Hello World and moving all the way through the various stages, learning some basic functions of Go, and having a functioning application at the end. And I thought, well, that's great. I'll try that. And then kind of elevate, sort of taking that to the next logical step. What better way to learn Go than to commit to giving a talk on it? So that was my personal challenge at the beginning of December, was agreeing to this and agreeing to do this talk at Bristol Cloud Native in front of lots more people next week. And so I had to learn something. So what are we going to build? Remember, the criteria was we need something that's relatively simple, mildly useful, not boring. So I thought, well, let's build a web app, something that accepts some sort of user input, maybe queries a public API, and then renders some output back to the user. It's a common enough pattern. It's an interview question. And so that's what we're going to do. And what we're going to build is an application called TNG Search. This is going to be a search engine for every line of dialogue and stage direction in every episode of Star Trek: The Next Generation. Why? Who needs this? So I needed a public API to query for the tutorial. And there's a couple of awesome lists on GitHub of hundreds of public APIs. And there's, in every category you can imagine. And some require different types of auth, and some require no auth. The one thing they all had in common was that they're all super boring. Really, you can query basic stuff from a public API, and put it in a table and immediately fall asleep. So as I was struggling to, and I sort of went through a couple of iterations of this talk with different APIs and got to the point where I thought, well, no one's going to sustain interest in this because the actual stuff we're rendering is so boring. And then I stumbled upon a data set. Somebody had actually scraped the scripts of every episode of Star Trek: The Next Generation. There's a theme here. You'll pick it up in a minute. And they published this data set for use with the R language, which is a data science language. I thought, that's great. Well, I'll query that. That was just a data set on its own. There was no API. So I had to write that as well, which is another great way to teach yourself how to write a Go tutorial, is having to write another thing for it to actually work. It's also great timing because this is on tomorrow. So where my Trekkies at? No, okay. Again, there's a theme. So I guess I could have called this tutorial "Make It Go." If you think that's bad, there's a worse version of that pun. If anyone gets that reference, then please be my friend on Facebook, or ask me afterwards. Okay, let's go. So that's the end of the slides. And what we're going to do now, if I can get this to work. Where's my mouse gone? So come out of here, and let's go into here. So if I make it a bit bigger. So this is going to be in different parts, and we're going to go through, like I said, we'll go through, we'll start very basic, and I'm going to talk through as best I can the things that I've learned to build this app. It shouldn't take as long as it looks, with being 7 parts. But we're going to start off. So part 1, what do we always write when we learn a new programming language? We write hello world. So start at the top, package main. Go uses a packaging system for all its files, much the same as other languages like Java. Main is the package that you use if you want your program to be executable. If it's anything else, it's going to be a library. If you want it to actually compile to be run, you put it in package main, and you have to have a function called main. I'm assuming everyone here has at least gone slightly a step up from sort of scripted languages, and you're familiar with what functions are, in any form really of any language. If you're not, it's just a way of grouping together. Here's a bit of my code that does something. This is the main function, rather than just going through line by line as it runs. So what have we got in our main function? Straight away, some really weird words. Mux, : http.newServeMux. All we're doing here is we're creating a variable called mux. We're calling a library here called HTTP, which we've imported up here. One of the great things about Go is there's all these fantastic libraries which are written by people who are much better at this than we are. So you can just stand on their shoulders. And the HTTP library contains lots of stuff for running HTTP servers. We call a public function from that library called newServeMux. And here's this mux word again. Mux is just short for multiplexer. And a multiplexer is just a way of routing different URL requests. This is a little funny bit of Go notation. Go is statically typed. So a variable has to have a defined type. And when we do : equals, we're just saying you can infer the type by what we're assigning to this variable. So this newServeMux is going to return, there you go, returns a newServeMux. We allocate it to this variable mux. Before we carry on in main, let's have a look at this other function that we've run up here, index handler. This looks a bit scary, this bit here, but it's really not. This is just the signature for the function. And a signature in function is just how you tell Go what you want that function to do, what arguments it can accept, and what it can return. This function accepts 2 arguments. They're both from the HTTP library again. One is a response writer, and one is the actual request. So when a request comes in, you've got things like the actual URL of the request, anything you normally see in an HTTP request. So this function, when it gets called, it gets these 2 objects. It stores the response writer as W, and in fact, that's the only one we use. We're not even going to use R, so we'll ignore that for now. And then we execute another function using the W object to write something out. Don't worry about this byte thing for now. This is just because the response writer expects a stream of bytes. But this is just going to print out hello world to the HTTP response. So we define that as our index handler function. And then down here, we're going to say, okay, we've got our multiplexer for URLs. We're going to add a function to it with handle func. It takes 2 arguments. This one is the URL we want to respond to, which is just /. And this is the function we're going to use, index handler. So requests for / are going to be dealt with by the index handler function, which you've just seen is just going to write out hello world. And then finally, we call another function from the HTTP library, listen and serve. Give it 2 arguments. One is the port to listen on, and one is the multiplexer we just set up. Oh, now you've done it. So that means that it accepts a pointer, not a variable. But I'm not going to talk about pointers yet. So Go is a compiled language. It's also not a compiled language. So we can just run it on the command line with Go run. Oh, we're off to a good start. Let me try that again. Okay, so our program is running. And if I go to the browser, I'll make it bigger. Reload that, and look at that. Hello world, it worked. Thank you. Hello world always deserves a round of applause. Okay, that's part 1, easy peasy. Part 2. So we're going to add a few extra things here, but they're not that complicated. The first thing you might notice here is we've actually got more than one import now. We're importing something else called template, and that's because we don't want to have to write out a bunch of HTML and CSS as streams of bytes. So we're going to use Go's templating language, which is going to help us, and I'll show you how in a second. Here we're going to create a global variable, which is a bit messy. There's probably a better way of doing this, but we just create a variable called TPL, which is our template, that passes a file called index.html. Here's our index.html, very basic HTML. It's just got a search form. It loads a style sheet, and it's got a form here where you can enter a keyword search using an HTTP GET method. So anyone that's ever done HTML, I'm sure, has seen stuff like that. Back in our Go file, our index handler now, instead of printing out hello world, it's going to execute this template. And it sends the template the response writer. So that basically means when this index handler is now called, it's just going to render a template rather than print hello world. So let's run that and see what happens. This time I'll do it from the correct directory. So running our new Go code. Let's load it again. That's what it should look like. It was caching something. So that's almost right. That's our new index page. It's being rendered, but it doesn't look how it should look. And even though in our index file we can see, well, we're referencing this style sheet, but it's because if we go back to our main Go, we can see we've only got this single handler here. So every single request, regardless of what the actual URL is just going to go to our index handler. We can't get /assets/style.css. So we could, we could create handlers for every single file we need to render, all these static files. But there's a much easier way of doing it, which I've hashed out here. We create a file server, and we just say that basically we create a file server for this directory called assets, and then any request to assets, just pass that straight to the file server. Don't worry about doing anything clever. It doesn't need its own function. So if we quit that, save it, and run it again. Give it a sec. There we go. And now it's rendering with our CSS file. Just resetting the zoom. So it's starting to look a bit like a web app, and that's not very much Go code, and it's a really basic HTML file. The stuff that you get from using these libraries that other people have written is brilliant. You can, this is just boilerplate. Already we've got a functioning app. So what do we do next? We need to implement that search box. You actually need to be able to write stuff in here and to have it do something. So let's start in our main function here. All we do is we add another call to handle func to add another handler. So any request to /search goes to a function called search handler. and then we write search handler here. It's another handler, just like index handler, so it takes the same function signature. It takes a response writer and a request. And this time we'll use both. So the first thing we do is we want to access this request that we're getting, which is this. We get it as this variable R. Because the type of R is this request. There's various built-in functions we can access on it, such as this one, which tells us, what was the URL, and can we pull the strings out of that URL, and can we pass them, and ultimately get, as we saw, it's a get in the form. So when you do a search, it's just going to appear in the actual address bar. So we grab all that and we store it as this variable here, u. You might notice here we're actually creating two variables at the same time, and that's because the response to this is going to return two variables. It's going to return the thing we're interested in, which we store as u, and this thing called error. This is a common thing in Go, and it's basically just how you do exception handling. So if this works, then the variable u will have in it what we want to have in it, and er or other there'll be nothing in it. It'll be nil. And so this is a common pattern in Go. We just check to make sure to see if there's anything in If is not nil, we know something's gone wrong, and we can go, no, internal server error, write something out, and just quit back to the main function. Don't try and do anything else. Stop right here. But if is nil, we carry on. Everything's hunky-dory. We can create some new variables here. We'll create one called parameters using the query function to get all of the values from the URL. Then we'll grab the one we want, search key, by just using get. And if we go back to our index page, we can see our form. It's sending a get, and the key is q. So that's how we get that parameter there. So we get the search key. And all we're going to do with it for now is just print it out to the console. Search query is to test that it's working. There's a couple more imports that we got from doing all that. One of the nice things about using an IDE like this is it will just manage your imports for you as you code stuff. So let's run this. Now we should, if we go back to here, put in a word like, I don't know, enterprise. It's bound to come up. Now it doesn't render anything because our search handler isn't rendering anything. It doesn't call a template. But there's our query. We've grabbed it from the URL and we've passed it, and we've got that search term. So we've achieved the first thing, which was to grab some input from a user. Okay, where do we go from here? So on to part 4. We're whizzing through it. Part 4 gets a little bit scary because there's this thing here called a struct. A struct is something that it's one of these things that puts a lot of people off Go when they're starting to learn it, but it's really very simple. Before we get onto that, let's go have a look at our search handler again. Now we know that just accepting the input from the user is not going to do anything. We need to query this public API, this fantastic public API that this benevolent person has created, which will respond to searches for dialogue from TNG. So in our search handler, we're doing our error checking here, and we're getting this search key. Ignore that for now, but we've got this endpoint here. It's hard-coded, which is not great, but we've got our endpoint there. We send it the query, and then we do some error checking. We make sure that we didn't get an internal server error from that API. This is interesting. You have to close that connection, but we don't want to do it straight away. So we just use the keyword defer, which means when you finish doing what you're doing, close that connection, but don't do it right now. If we didn't get an internal server error, that's great, but we also want to make sure we got HTTP 200 back. Everything's all hunky-dory. So how do we store the results of that query? This is where structs come in. So when you want to store something more elaborate than a string in Go, there's various basic types, and I won't go through them all now, but if you want to store something that you would expect to get as part of a JSON response, as you would expect from an API, you need to create your own type, and that's where structs come in. So a struct is just a new type, and we're going to create a type called dialogue, because we know that from the contract with our API that we've got, we know this is what our API is going to return. A bunch of strings, episode name, act, scene number, and we can annotate these definitions in this struct definition with what the actual key in the JSON response is going to be, and we'll use that in a minute. But it's very simple to declare a struct. This is all you do. Just say type the name you want to give it, the keyword struct, and then all of the fields. And these can be strings or ints or floats or other structs, structs within structs, structception. But this is a really simple struct. The only slightly fiddly thing with this is you may have noticed these two square brackets here. In Go, this denotes a slice. If you haven't heard of this, you can think of it as an array that's mutable. So everyone knows what an array is. In Go, an array is immutable, and a slice is just a way of having an array that is a bit more flexible. It can be dynamically sized. So our struct is actually a slice of these things, not just one. And that's because we know our JSON response is going to contain multiple results. Even if we only find a single episode that contains the line of dialogue we're looking for, it's still going to be part of a list. And your struct has to match the format of that JSON, otherwise it will not work. And then we use a really nice, clever bit of code that someone else wrote. Here, we've got our response from the request we made to the API. We use a JSON decoder, and we just bung it straight into a variable that we've created. Because we know that this variable, which I skipped over, but here is where we declare this variable of type dialogue. And we know that the format of our struct is going to match the format of the JSON response. So in one line, we don't have to parse anything. We don't have to iterate through anything. We just go dump it in there, decode it into dialogue. We do a little bit of error checking again. This is a little bit of debug here. There's a library called Spew, which is really useful because if you're developing a Go program and something goes wrong because you've defined the struct incorrectly and your JSON response doesn't match it, and it will not work, Spew just prints out the structure of your struct to the terminal. And then instead of sending nil to the template, which is what we did before, we're sending that struct. So everything we grab, we're sending it to the template. Everyone with me? Ready to see if it works? So remember, this is going to query a public API that's running on the internet right now. Let's think of something. I'm just going to make that slightly smaller so we can fit some on the screen. We'll give it a keyword that won't return quite so many results. Anyone remember the episode Darmok? Wrong crowd. Okay, so we search for Darmok. Nothing's rendered because we've sent this struct, the output that we've got, we've sent it to the template, but we didn't change our index HTML file. So it doesn't do anything with it. It's in the matrix somewhere. But if we go back to our terminal, because we use Spew, look at this. We have results. So this is the result of our query to our public JSON API passed through the struct, and this is just outputting all of the results that we got. The beast at Tanagra, Darmok and Jalad. Come on, guys. Right. Okay. So we've taken an input from the user. We've queried a public API. What do we do next? We need to render the results. So what are we going to change in main.go in part 5? Absolutely nothing. This is all exactly the same. All we're going to do is change our index file. If I quickly show you our previous index file, it just had the search box. The index file in part 5 has a results box. It's this container here. And all it's going to do is render a list, and the CSS magic will make it look not like a list. But there are some things you can do in functions in templates in Go. You can call some functions. One of them is range. So you can basically iterate over things in that struct that gets passed to the template. The reason it's referring to dot is because it's basically the parent struct that's passed to the template. We're not diving deeper into anything to iterate over it. We're just iterating over the main struct that we're passing to it. And then once we're inside this loop, which ends here where it says end, we can access the fields of that struct: episode name, text, who said it, the scene number, all this good stuff, because those are just fields of the struct. It's really easy. We can also do if statements inside templates in Go. So we know that this data set contained dialogue, but also stage direction. And thankfully, there's a field in there, text type. If the text type is speech, it's because a character is saying something. If it's not, it's going to be stage direction. So we don't render who's saying it, we just render the text. So it's that simple. We haven't made any changes to our actual Go code at all, just to the index file. And if we run that, rerun the query, and it's caching the style sheet again. But, come on. There we go. A small round of applause for that, I think. Thank you. Dharma Congelata Tanagra. Anyone got a search they want to run? There's hundreds of episodes, every line dialogue, anything you're desperate to find out where it appears. He didn't call it a float though, did he? It was in the inner light, I know, but you know, I could tell you like every time they said "Shut up, Wesley," 4 times, all in the same episode. Yeah, I started playing a fun game where you have to try and find a result that only matches a single episode. I think, 2 bastards. But this is really cool. So it's, you know, it's taking our search, it's querying this API that's running. It's actually running in Cloud Run somewhere in the world, passing the JSON, rendering it to the user. This is how far I got with the other APIs, and they didn't look very interesting. So what can we do to make this more interesting? It's 8:30, so I'll speed this up a bit. Oh, no, don't do that. So in part 6, this is where it gets complicated. I thought, well, you know, this is great. It's proving what it can do, but it doesn't look very interesting, you know, I mean, unless you like reading scripts. It'd be great if we could have some pictures in there, like a shot of the episode itself. That wasn't in that data set, though. It didn't exist. And I wasn't going to go through and add that. But I thought, well, one of the things you do get in that data set, if you have a look through, is, I can see it, this here, which is the ID from the Internet Movie Database. So I thought, brilliant, I'll query the IMDb API, grab that picture, stick it in the output. There isn't an IMDb API. There used to be, but they like money, so they don't do it anymore. There is something called the TMDB, which is like a community IMDb that does have an API. So in part 6, we have a bunch of new stuff. But real quick, all we're doing here is our dialogue struct is the same, except now it's not a slice. This type now is a single result of dialogue, because what we're going to do is have a new parent struct called results that we're going to send back to our template. Inside, we can put anything we want. So we're going to put the original search key. We're going to here create a slice of dialogues. So this is where we've now got all our multiple dialogue results. And then we've got this new thing here called images. Images is a map. If you're used to maps in Java, it's roughly the same thing, or like dictionaries in Python, just key value pairs. The key is a type string, the value of type string. And this is where we're going to store key value pairs of IMDb IDs and URLs to images that we can render. Where do we get those? From the TMDB API. So again, here's another struct, because we're going to query the API of this thing. We have to have a struct that matches the results we're going to get from it. Now, it starts to look sort of slightly big and scary, but it's the same thing again. It's quite straightforward. This API can return a bunch of stuff to us. It can actually return multiple results for movies, people, TV shows, seasons, because the endpoint that we're querying, we're just giving it an ID, and it's going to search its entire database. But we know, because we're going to give it the specific IMDb IDs, we know these are from episodes of Star Trek: The Next Generation. The only thing it's going to return to us is TV episode results. In fact, we know it's only going to return a single result, or it's not going to return anything because it can't find it. But even so, our struct has to match the format of that JSON output. So we have to allow for a struct of movie results and person results. But with this JSON annotation here, by just putting minus instead of the actual JSON key, we can say, I don't want it, ignore it. So just do nothing with it. And we don't have to worry about anything that's contained within those results. It will only decode the TV episode results here. And this API will give us something like the air date, which is interesting, the production code. Even I'm not nerdy enough to care about those, but it will give us this thing called still path. And this will be a URL to an image for the episode. So in our search handler, we've added a little bit of extra code. This is all the same as before. You know, we're decoding the results of our original API, but now we're creating a variable called results, which is our new struct, contains all those new things. We're decoding into results.lines, and then we're running this new bit of code here. We're just going to iterate over, we're going to range over all the lines in our results, create a new object to store the results of a query to the TMDB API, grab the ID. This thing here, what we're doing here, underscore OK, colon equals results. This is basically just saying, do we already have this key? Have we already queried this? Because, you know, if I do a search for Darmok, I'm going to get 37 results. They're all the same episode. I don't need to make 37 queries to this API to get a still image. I can do it once. That's the whole point of having a map. So this is going to check to see, does that already exist or not? If it doesn't exist, we query the MovieDB API. We do the similar sort of error checking we saw before. And then we decode that response. And then we check the length of that field, TV episode results. Now we know, like I said, because we're sending it the IDs, it's not going to be some random TV show. It's either going to be the result we want, in which case we just grab it and store it in our images map. And if for some reason it didn't work, we didn't get the image we want, we just hard code an image, which this is just a shot of the crew. And then we render the template like before. Now, before I show you the next bit, the template is a little different because now we're not ranging over the main struct, we're ranging over lines. And then as we go through, we're adding an image here. And we can, even though we're ranging over the lines field of our struct, we can back up and grab the images field as well. And if there's an index for the IMDb ID in our images map, it will render the image. One last thing we had to do in main.go, the TMDB API requires an API key. I'm not going to hard code an API key in here. So we're going to use an environment variable. And we're just going to check that it exists. If it doesn't exist, then it'll just quit. But as long as it exists, it can use that API key here when it sends the request. So let's see if this works. I think I've already got my API key set. We'll find out in a minute. If I run this, I have got it set. So let's just, oh, I can do this. There we go. Okay. So let's try Romulan. Oh, that's good. Give it another chance. So at this point, it'll spin for a second because every single result, I probably should have done, every single result, it's going to make that query if it doesn't exist in the key map. And this is caching the style sheet again. So if I reload it again, not like that, then it should actually render the images a bit of a nicer size. There we go. And now we're querying two different APIs, combining the results and presenting them back to our user. And we get these lovely screenshots. The Angel one, that's a terrible episode. Oh God, how much do they talk about the Romans then? Heart of Glory. I mean, these are great. I could just look at these all day. And there you go. We've built our web app. You know, I think this is going to be a big hit. I'm going to make lots of money off it. Any other searches anyone wants to try? So how many results are Borg? So QWho is first time we see the Borg, of course. Then we'll get lots in QWho, yeah, and then we'll eventually get down to Jesus. Look at that, Tin Man Evolution, Best of Both Worlds. There you go. Who thinks they can get a single search result with a word? Okay. Not once. Let's try triple singular. Nope. How many times was Kirk mentioned? Oh, and the naked now. Classic. 3 times. 3. So, yeah. Can we improve on that? Probably not. Right. Finally, before we finish up, let's deploy it to Cloud Run just because we can, just to show you how super easy it is to do. Here's my Docker file. I'm just building it using Golang image, but then I'm running it from this distroless base. Is anyone familiar with GCP's distroless endeavors? This is Linux with nothing in it. There's no package manager. There's nothing, and because Go compiles to static binaries most of the time, that's another story. Then yeah, you can just do this. So if we let's use Cloud Build build our Docker file. Let's go to the Cloud Console. That's not it. Spell it right. Here we go. Let's go to the container registry. Shouldn't take too long. There's the API running in Cloud Run. I've got it limited to a single instance, so it doesn't cost me too much money. So that's pushed. You can see it in our registry. Now, can I deploy this from the command line? The answer is no, because I haven't looked up how to send environment variables from the command line. So I'll do it through the console. I'm just going to grab my API key, put it in my clipboard, go to Cloud Run, create a service, call it TNG search. I don't care where it runs. Wait, no, sorry. This is the actual container, so let's try that again. This is our container, that's what we want. That's the service name, that's what I was trying to type in there. It can run in Iowa, it doesn't really matter. We're not going to run it on Anthos because I'm not a millionaire. We're going to allow unauthenticated invocations, which means we're going to make it public. But we're going to need to send it an environment variable or it's not going to run. It'll just quit and Cloud Run will give us an error. So we'll set an environment variable of API key, paste that in, hit create. Always test in production on a Friday. If we wait a few seconds, so look at that. Now, see, it says it's ready. It won't be ready yet. Oh, it is. Look at that. So this is now running in Cloud Run. We can put in anything we want. Let's do Darmok. Personal favorite, Darmok and Gelada Tanagra. And that's our Go web app. So, thank you. So, have we now learned the basics of Go? No, maybe not. For me, this was about, when I tried before, just nothing stuck. And when I looked at other Go code, it just terrified me, or it didn't compute. And since seeing the Pacman Go talk and writing this, now at least, it's starting to click. I can go back to Tour of Go and go by example and have some context to do that. So, next time, I'll have a go. Thanks for watching. I've actually written this up as a series of blog posts. If you want to follow along all the codes there, the address of the API, and you can build your own TNG search engine. Other sci-fi series are available if you can find the data sets. And please come to our next meetup in February. We've already got talks booked, which is amazing. We've got a talk, another one from JetStack. I don't know if I should say what it is because the boss is here, but lying to your boss is Slackbot. And we've got to talk about how it's always DNS. But in this case, it's always hybrid cloud DNS. Thanks very much to Just Eat. They hosted us a bunch of times last year, and they keep buying pizza for us. It costs them a bunch of money. They get nothing in return. So thank you, Just Eat. And if there's any questions, remember who had their hands up at the start. Ask them. Thank you.